Welcome to the GCSE Statistics Higher Session 3. This session is focused on extending GCSE topics and consists of 4 subsections: stem and leaf, histograms, averages, capture, recapture method. Stem and leaf diagrams. Leaves must be ordered. A key is essential, and you must be able to find the mode, medium, interquartile range, and identifying outliers. Occasionally, you are asked what type of skew does the diagram or graph show. Example number 1. During one milking session, a farmer records the amount of milk in litres collected from each of his cows. The results are shown below. Complete this information here with a stem and leaf diagram. We have a key already. We need to put these numbers in order. We can see here they're in order, but in the correct rows. Our first number 12, we have a 1 here and a 2 here. Our second number 18. 1, 8. 26, next row, 2, 6, 8, 8. 3, 1, 4, 4, 4, 31, 34, 34, 34, and then our next row, 42 and 43. Check that we have the numbers, correct numbers here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so let's work out now from here some averages. First off, the mode, the most common value. Which number appears the most? We can see here we have 3 4s. This number is the mode, 34. Make sure you include the 3, not just the 4 here. The medium. The medium is the middle number. We have 11 numbers. The middle number will be the medium. The medium will be here. 5 numbers below, 5 numbers above. You may also want to use the list to identify this number. The medium, 31. The mean, the third type of average. The mean is found by adding up all of these values and dividing by how many there are. In this case, 11. Adding up all of these numbers gives us a total of 330. Divide by how many numbers? 11. Gives us the mean of 30. Then to work out the interquartile range. The interquartile range is found by taking the upper quartile, Q3, and subtracting the lower quartile, Q1. First, we need to use our mean, our medium, and our list to identify our upper and lower quartile. So the median, cross out. Look at our list here of 5 numbers. The middle number, 26, is the lower quartile, Q1. Out of our 5 numbers this side, the middle number is 34, Q3, the upper quartile. So the interquartile range in this case is 34, subtract 26, which is 8. Now, this question goes on and tells us that a particular cow produced 12 litres of milk. So that must be this one. We call this here 12 litres of milk was produced by Buttercup. In the next milking session, Buttercup produced more than 12 litres of milk. So here, this number has increased. We don't know by how much, but all we know is it's gone up. And we're told the amount produced by all the other cows stays the same. And asked what effect would this have on the mean amount of milk produced by all the cows? So if 12 increases, our 330 is going to be increased. A larger number divided still by 11 is going to mean that our mean will increase. So what is the effect? The mean gets bigger because the total amount of milk has increased. In this question, we might also be asked about outliers, such as, is 43 an outlier? Now, it's not good enough to say yes or no. We need to use, on the previous slide, the definitions of an outlier. Now, 43 is at this end of the distribution, the higher end. So looking back here on our notes page before, we will be using this to identify the upper end. Is 43 an outlier? So we're going to take the upper quartile, Q3, and we're going to add 1.5 times the interquartile range. So in this case, we have 34 add 1.5 times 8. 34 add 1.58 is 46. Now, 43 is less than 46. 46 is the limit. Any number above 46 would be an outlier. So in this case, 43 is less than 46. Therefore, no, it is not an outlier. So 43 is not an outlier because it is less than 46. Histograms, really important. The area of the bar equals the frequency. The height of the bar equals the frequency density. You need to be able to draw, interpret, and use a test for normal distribution. So one key thing you're going to have to know to be able to help you draw and interpret is in relation to how to calculate frequency density. You must know that frequency density is equal to frequency divided by the class width. Frequency density is equal to frequency divided by class width. Now we can rearrange that to say frequency density multiplied by class width is equal to frequency. And that might be helpful when we're working backwards from the frequency, the histogram, to finding the tables, the missing frequencies in the table. So you must know this. This is really important to be able to draw your histogram. So write this down on your paper now if you do not know it. Now, in terms of other parts that are often associated with this question, you're often asked to find the mean in the form of a table and the standard deviation, and this will be related to a histogram question. Following that, you'll be asked to test for a normal distribution. If it is a normal distribution, we must have a symmetrical distribution, and 95% of the distribution needs to be within 2 standard deviations of the mean. So provided 95% of the distribution is within 2 standard deviations of the mean, this is a normal distribution. For further information as to how to calculate the mean and the standard deviation, there will be a further session on that. However, we will be looking at some questions related in this session to the histogram. Example number 2. In an experiment, a psychologist records the times, X seconds, for 50 people to complete a puzzle. We're asked to use this information to draw a histogram. So a histogram is used for continuous data. You can see here that we have class intervals. We have X less than or equal to 40 but greater than 0. And we have 10 people for this frequency. We have some columns here we'll be able to use to help us. So first off, let's identify the class width. Between 0 and 40, we have 40. 40 to 60, 20, 20, 20 again, and here we have a class width of 80. Using this now, we can find the frequency density. Remember, the frequency density is equal to the frequency divided by the class width. So here we take 10 divided by 40. Calculating each one of these frequency densities, 0.2425, just make sure that looks like a 2, 0.45, 0.6, 0.45, and lastly 0.125. We're then asked to draw a histogram with this information. The axes are not drawn for us, but we need to pick a sensible scale. We can see here that going up in point 1, for example, to here, 1, 2, 3, 4, 5, here, 0.1 will leave enough space to go up to 0.6. So here, 0.2, 0.6 is our largest frequency density. Here 2, 3, 4, 5, 6, 0.6. And this side here is our frequency density. Going across the x-axis, we have the time here. We go from 0 to 40. So each big block is worth 40. 80, add 40, 120, add 40 again, 160, and here 200. And this is our time in seconds. Now, taking your ruler, we're going to plot the frequency density here against the time, and the class widths are important. So our first class width goes from 0 to 40, and the frequency density is 0.25. So from our line here, 40 going up to 0.25. Ensure it's in the right place there. And then drawing a line across here at 0.25. Okay, the next one, 0.45, and we're going over to 60. So the line is going to go up from here up to 0.45. Here and across. We can then extend our line here. Up to meet the other bar. Okay, the third bar goes over to 80 and up to 0.6. So taking this again, we can extend all the way up to 0.6. $80 up here, drawing across, and then from 80 to 100, here, going up to 0.45, so back in line here, and across. And then lastly, from 100 to 180, which is here, up to 0.125. Going across here. Okay. So really making sure here that we have all of our points join up as straight as possible as well. Here. And here is the completed histogram. So I've just transferred that graph over here onto the next page. This is example number 3. We're asked to shade the region in the histogram which is within 2 standard deviations of the mean. Now we're told here in the question that the mean is 75 and the standard deviation is 840. So we take the mean, 74, and we will add 2 times the standard deviation. 74 add 80 is 154. So taking your ruler out to identify where 154 is, we have here 120, here 140, here 150, and then further over 154. So we're asked to shade the region which is within 2 standard deviations of the mean. So here we have from our mean adding on 2 standard deviations, and we can see on the other side the mean subtract 2 standard deviations still means that everything here is included. So all of these values. So the shaded region, just to make that clear, is everything this side. So the shaded region is less than or equal and equal to 154. We're then asked to find the proportion of people represented by this region. Well, taking a look back at your table, it includes all of these people here, which add up to 40, and some more. So the first part that it includes are 40 people, plus the frequency density, 0.125, multiplied by 54. And that's related to this part here. This goes up to 100 and then up to 154. So this is where the class width of 54 is coming from. And here is the frequency density we're using to be able to find the frequency. So adding these up, we have a frequency of 46.75. So this is the number of people. Out of the total, we have 50 people altogether. So as a proportion, or a percentage, if you want to find a percentage, times by 100, 93.5%. So 93.5% of the people are less than, as you can see from this side, or within 2 standard deviations of the mean. It is then claimed that the time to complete the puzzle is normally distributed. This here is the test for normal distribution. Our bell-shaped curve is here. We have our mean in the middle, and we have 2 standard deviations, above and below. This part here must equal to 95% of the distribution. So this part here must only be, here must be less than 2.5 and here also 2.5%. We can see here that 93.5% is less than 154. So we can see here that we have symmetry and that 95% of the data is within 2 standard deviations of the mean. Example number 4. We now need to look at how to calculate averages from a table. This includes finding the mean, the median, and the mode. Let's take a look at example number 4. A survey was done to count the number of eggs in blue tit's nests. The data is recorded in the table. Here we have the categories for the number of eggs, 7 to 12. Here we have the frequency. How many of the nests had 7 eggs? 2 of the nests had 7 eggs. If we have 2 nests with 7 eggs, altogether we have 14 eggs. This column here, fx, is found by multiplying our variable with our frequency. Similarly here, 8 times 8 gives us 64 eggs. This is enabling us to find the total number of eggs. Our missing value here is 176. Our missing value here is 108. Our total, the total number of eggs, is 620. If our data is grouped and we do not have a single value for 8, for example, we could have 0 to 4. In this case, we must take the midpoint, 2, and this becomes our value for x. Then we multiply our frequency. If we do not have discrete data and the data is grouped, we must find the midpoint to multiply by our frequency. In this case, we do have single data. We multiply it by the frequency to find the frequency times the variable, which gives us our total. This is needed to find the mean. The mean is found by a formula that looks like this. You may be familiar with this. This sign here says the sum. It's a mathematical code. It's a Greek letter that represents the sum of fx. All that means, the sum of fx, just means the total. Okay, so when we find this out, it's 620. When we look at the number below, we have the sum of f, the sum of the frequencies. That's this number here, which we find by adding up the frequencies. Adding up the frequencies, we get 62. So we divide 620 by 62. Dividing these two numbers gives us the mean, which is equal to 10. When asked to find the median, we need to find the middle value. We have 62 values. 62 divided by 2 will give us the middle value, the 31st value. This corresponds to the median. This is not the answer. We must find where the 31st value is. How? By looking here at our frequency and adding an additional column for the cumulative frequency, the running total. Our first category is simply 2. Our second category, 2 plus 8, is 10. 10 plus 12 is 22. Still not high enough. We're looking for the 31st. 22 add 15 is 37. So this is where the 31st value is. Here we have the 23rd, 24th, 25th, 26th, 27th, 28th, 29th, 30th, 31st, all the way up to the 37th. Therefore, our median corresponds to 10. So here we have 10. So the mean and the median are the same value in this case. Lastly, looking at the mode is the most common value, the most popular value. We find this by looking here at our frequency column and looking at which category is the most popular. What has the highest frequency? This is our highest frequency, therefore the mode is 11. Capture-recapture method. This is used to estimate the size of a population in cases where counting is impractical. The classic example is the number of fish in a lake. When doing this type of method for estimating the size of the population, the system must be closed. So we couldn't do this in, for example, a river or a sea, an ocean. So the lake is a closed system. This is really important. The method is as follows. First, a number of members of the population are captured. So someone goes to the lake and captures a certain number of the population. What they have captured, in this case if it's fish, they then tag the fish. They mark them in some way that's not going to harm the animal or the thing that they are counting. And then they are re-released back into the population. And at a later date, a further sample is taken, so a second sample, and the number of members that are tagged are counted. This gives us an estimate of the population size. You need to know this calculation. The population size is estimated by n divided by n. N stands for the number of population originally tagged. M stands for the proportion, really key, not number, the proportion of the second sample tagged. Now, there are a number of assumptions that we need to make when carrying out this way for estimating, this method for estimating the size of a population. And they're called the conditions for validity. First, the number in the population remains unchanged between samples. So the number in the population must stay the same. We're assuming that it stays the same. We're also assuming that the marks or the tagging can't come off or they're washed out, so that when you collect the second sample, you still need to be able to see whether this was a member of the population that was originally tagged. The third assumption that we make is that tagged members, those with the markings on of the population, spread evenly throughout the population. Given that they've just been tagged, they don't all stay together. So one of the third conditions is that the population that have been tagged spread evenly throughout the population. Example number 6. Mary wants to estimate the number of fish in a lake. She catches 40 fish. This here is the first sample. She marks them and puts them back in the lake. First sample that are tagged. This is the number of the population originally tagged. So our estimate, n divided by m, this number is 40. Later, she catches another 40 fish and finds that 5 of them are marked. So m is equal to the proportion, not the number, not 5, but 5 out of 40. the proportion. So we're taking our 40 and dividing by 5 out of 40. Or as a decimal, 40 divided by 0.125 gives us an estimate for the number of fish in the lake to be 320. Always with these questions, you're then asked to write down an assumption, 1 or 2 assumptions about what you have made about the population of fish in this lake. So you need to repeat one of the things on the previous slide. The number in the population, unchanged between samples. The tagging or the marks could not come off. And that the marked fish spread out evenly within the lake. So it's now time for you to do some questions. Press pause on the video and complete the question booklet. Once you have completed the question booklet, come back to the video and press play. We will then go through the questions together. Question number 1. A farmer records the weight of plums to the nearest kilogram that were produced by each of her 15 plum trees. The results are given below. Complete the ordered stem and leaf diagram below. So putting these numbers in the stem and leaf diagram. Our lowest number is 42. 2 is placed here. 50, we have no values that are 50. 60, we have 65. 66, 68 twice, and 69. We can see here 65, 66, 68, here and here, and 69. 70, we have 2, 73, and 77. 72, 3, and 7. 80, we have 0, 1, 4, 6, and 9. 1, 4, 6, and 9. And lastly, we have 92. We're told that there's 15 plum trees. Check you have 15 numbers here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Check your numbers are also in increasing order. We're asked to find the median. The median is the middle value. We have 15, it will be in the number in the middle. In this case, our middle number here is 73. The interquartile range. The interquartile range is found from taking the upper quartile, Q3, and then subtracting Q1, the lower quartile. Using here, we can identify our lower quartile. Here, we cross out our number here, and we have 1, 2, 3, 4, 5, 6, 7. Middle number is here. This is quarter 1, the lower quartile. 3 numbers below and 3 numbers above. Here, 3 numbers below. This is quartile 3, and then 3 numbers above. So here we have 84 subtract 68, which gives the interquartile range of 16. A farmer thinks that the tree that produced 42 here is diseased. Is 42 an outlier for this data? Give a reason for your answer. So 42 is at the lower end. So the test that we're going to do is the lower quartile, Q1, subtract 1.5 times the interquartile range. So we have quartile 1, 68, subtract 1.5 times 16, which equals 44. 44 is the limit. Therefore, 42 is less than 44. Therefore, it is an outlier. We're told that the farmer removes 42 from her results. We're then asked to work out the median for the remaining 14 results. Now we have an even number. So we have two numbers in the middle. Here, 73 and 77. Two numbers in the middle. 5 numbers above, 5 numbers below. Because this number is no longer included. So here now we are taking the average of these two values. 73, add 77, divided by 2. Gives us the new median of 75. Question number 2. The parking times in hours for 118 cars in a car park are summarised in the table. Draw a histogram for the data. First, we must identify the class width. 1, 1, 2, 2, and 6. We must then find the frequency density, which is found by taking the frequency and dividing by the class width. Here, our frequency is 16, divided by our class width, 1, 16. 24, 15, 12, and 4. Looking here, we must then create a scale for this. Here, 5, 10, we need to go up to 24, 15, 20, and 25. This here is the frequency density. The parking time in hours is already along the x-axis. So our first bar from 0 to 1. Here we have from 0 to 5, and we have 15 squares. 15 divided by 5 means that each one is worth a third. So 3 squares is equal to 1. So we will extend up 16. Our next bar goes to 24. So we'll extend now to 24 and then take the bar across here to show the 16. Our next one is from 1 to 2. So we go across 3 as well up here to connect to make the second bar. We mustn't leave any gaps between our bars. This is continuous data. Now here from 2, we go across to 4. So that will be all the way to here. And we have a frequency density of 15. So here going up to the line for 15 and across. Our fourth frequency density is 12 across to 6. So from here up to 12. 12 here, and then across. Here from 6 now, all the way to 12, 3 and 3 again for 12, frequency density of 4, so a lower bar here. So take time calculating your frequency densities and then ensuring you read your scale correctly here along the axes to plot the histogram on the graph paper. Question number 3. The table gives information about the lengths of the reigns in years of English kings and queens since the year 1014. Here we have our groups of years, the length of their reigns in years, the frequency, and then two spaces here to help us to be able to complete the histogram by calculating the class width and the frequency density. So our class width here is 5, 10, 10, 20, and 20. Our frequency density, working out each one, 2.4, 1.1, 1.2, 0.4, and 0.2. We then have the first three bars drawn for us, just check the numbers correspond, and then completing the next two bars. First off, here we're looking at from 25 up to 45 and a frequency density of 0.4. Across here. And our next bar from 45 to 65 with a frequency density of 0.2. So just to here and across. Part B, we're asked to estimate how many English kings and queens reigned from between 20 and 50 years. So between 20 and 50, taking another pen, marking here, we can see that it goes from here, over slightly, to 20, which is here. So we're trying to estimate the frequency, the number reigning between these years. So we can see our bar here, our third one, between 25 and 45. We know the frequency here is 8. That's from here. This part here is half, the section here is half of the whole frequency. So our total frequency here is 12, so this part here is 6. Here we have 1/4. We can see 1/4, 2/4, 3/4, 4/4, a whole. So this section here is equal to 1 because our total frequency is equal to 4. So estimating the number, we have 6 plus 8 plus 1 gives us a total of 15. Question number 4. A shoe manufacturer measured the length, L millimeters, of 200 people's feet. The results are summarized in the table below. The incomplete histogram shows the information about these data. So we don't know what our scale is here. So first part is to identify the scale. So if we have our class widths identified, writing next to them, we have 10, 10, 5, 5, 5, 5, 10, and 10. 15 we have at the end here. So the class widths are going to help us. We don't need to calculate the frequency density of all of them. We need to know enough to be able to work out what the scale is for these bars that have been drawn already. However, if you do calculate the frequency density, we have here 0.9, 2.5, 5.2, 6, 6.6, 6, 2.9, and 1.2. So using what's been drawn here, for example, we've got a whole number here, 6, between 255 and 60. So this here must be the frequency density for 6. 5, 4, 3, 2, 1. Okay, now using these, we can then find out how high to draw our bars to complete the histogram. The parts that we need to draw are the last two sections here and here. So taking our ruler out, we can see here we're going from 270 to 280, up to 2.9, almost at 3, half the square away, and again across here to complete the bar. The next one is from 285 all the way to 295 here on the end, and we're going up to 1.2. So that's 6 squares up, making sure that's as straight as possible, completing the bar with the top part here. Now, following the completion of the histogram, you then have several questions in relation to interpretation. The first part, B, you're asked to discuss how these results could be helpful to the shoe manufacturer. Histogram does not show how many. Remember, the height of the bar shows the proportion. So here, the histogram might be helpful because it shows the proportion, keyword, not the number, the proportion of each shoe size. And this might help when ordering. Part C, we're asked to calculate an estimate for the median foot length and give our answer correct to 2 decimal places. So we're asking to find the median. Looking at how many people we have here, and we were told at the beginning we had 200. So the median is going to be the middle shoe size, the middle person here, their feet size, shoe size. So 200 divided by 2 gives us 100. The 100th person, where are they? A cumulative frequency is going to help us here. 9 plus 25 makes 34. We're looking for the 100th person. 34 plus 29 is 60, still too low. 60 plus 30, 90, still too low. 90 plus 33, 123. This is where the person must be, in this group, between the 20 here and the 265. We're then asked in part D, what probability distribution can we use to model the length of these feet? We can see here that we have a symmetrical distribution, an almost symmetrical distribution. So the probability distribution that can be used to model the length of these feet is called a normal distribution. Question number 5. The manager of a supermarket records the times, T minutes, to serve 200 customers. The results are summarized in the frequency table. We're asked to start with to calculate an estimate for the mean. To be able to calculate an estimate for the mean, we must find the midpoint and multiply this by our frequency. Our midpoint here is 1.5, 4, 5.5, 7, and 10. We then multiply this with our frequency to find fx. Multiplying these together gives us values of 13.5, 188, 209, 420, and 460. To be able to calculate the mean, we must take the sum, the total of fx, divided by the total, the sum of the frequencies. Adding up all of these numbers here, we have 1290.5 divided by 200, the total of the frequency, which gives us an estimate for the mean as 6.45 minutes. In part B of this question, we're asked to then draw a histogram for this information. To be able to draw a histogram, we must calculate the frequency densities by taking the class width, which we can see here as 3, 2, 1, 2, and 4, the class width here. Take our frequency divided by our class width to give the frequency density. So our first one here will be 9 divided by 3, which is 3. Then our frequency, 47 divided by 2, 23.5. 38, 30, and 11.5. Here are our frequency densities. Our highest value is 38. Plotting this here in 10, 20, 30, and 40 will give us a good scale. First, then take your ruler to do the bars. Our first one goes from 0 to 3, and we have a frequency density of 3. First off, I'm going to draw up the higher column here for 23.5, and then join across here for our bar of 3, for our frequency density of 3. Next, we go from 3 to 5, up to 23.5, which I have already prepared here, carry on up to 38, and then connect across here to make 23.5. The third bar goes from 5 to 6, so just across here. And then joining here for the 6. The next from 6 across to 8, and we are going up to 30. Join across here. And then lastly here, from 8 all the way to 12, up to 11.5. 10, 11, and then halfway, 0.5. Connecting these now, we have a completed histogram. We're then asked to calculate an estimate for the mean time to serve these customers. We actually need to find the number of minutes as an estimate, okay? We can see which group that the medium is. We have 200 customers. We're looking for the 100th customer. And we can find that from the cumulative frequency by adding these up, 56, adding up here to 94, and then 154. So we know that the person is somewhere in this group. So we expect the answer between 6 and 8, but we need to actually work it out. So here we're going to use our histogram to help. So we're looking for the median. First off, we know here that it is going to be 6 and a bit more. How much more? So first off, we're looking at how far into this group we are. We're at 94 and we're looking for the 100th person. So we're 6 into the group, divided by the total of the group, 60. And then we multiply by the size of the group, the class width, which is 2. And this is going to be the additional proportion, the additional amount into the group. So we have our answer here of 6.2 minutes. So in this case, when calculating the median, we're actually asked to estimate exactly where it is. So the median here, 6.2, is this line here. An estimate for the median, I'll draw the line up, is here at 6.2. So this is the estimate of the median, the median. We're then asked or told that it's claimed that these times are normally distributed and asked to discuss whether this claim is true or false. Is this normally distributed? A distribution that's normally distributed must be symmetrical. The mean must equal the median. Now we've just calculated the mean to be 6.45 and an estimate for the median to be 6.2. These are not equal. Therefore, the claim is false because the mean is more than the median. They are not equal. Therefore, we do not have a symmetrical distribution. Question number 6. Lincoln greenhouses grow Shirley tomatoes. A sample of 26 tomatoes was taken. The weights of the nearest 5 grams of the 26 tomatoes were. Complete the frequency table. So the 50s, the 55s and 60s are completed. How many 65s are there? 1, 2, 3, 4, 5, 6, 7, 8. 8 altogether. Find fx, 65 times 8, 520. How many 70s are there? 1, 2, 3. 3. Check that the total adds up to 26. Multiply your 3 by your 70 to get 21. And then find your total for fx. This will help us to find the mean. The mean will be the sum of fx, 1,560, divided by 26. Estimate for the mean is 60. We're then told that supermarkets want each tomato they sell to be about the same weight. What other statistical information might the supermarket need before deciding whether or not Shirley tomatoes will meet their requirements? So they want them to be about the same weight, so not much variation. How can we find more information about the variation? Well, any of these reasons is going to get you the 1 mark available. We're going to need to collect more data. We're going to be able to find the range, what the minimum size is, what the maximum size is, to find the interquartile range, to see if there's any outliers. All of these things to find the standard deviation. All of these things will help the supermarket decide whether or not they would like whether Shirley tomatoes meet their requirements. So collecting further data and carrying out further statistical analysis. Question number 6. There were 64 tsunamis, which are tidal waves, between the years 2000 and 2009. The table gives information about the maximum wave heights in meters of the tsunamis. We're asked to work out which class interval that contains the median. How many? 64. Divide by 2 to find the median. Where is the 32nd? Cumulative frequency, 26. 26 add 8, 34. Here, we have already reached 32. So the class interval is the height less than or equal to 0.5 and greater than 0.2. We're then asked to calculate an estimate of the mean wave height of the tsunamis, giving your answer to correct to 1 decimal place, and you can use the blank columns to help. So here we have group data, so we must find the midpoint. Our midpoints are 0.1, 0.25, 0.75, 2, 4, 7.5, 20 and 45. Multiplying all of these together to find fx. This is f, this is x. Because we do not know here, we estimate by finding the midpoint. Fx is equal to 2.6. 2, you must show all of your working out. 12, 20, 60, check you have this. 60, and 90. How do we find an estimate? We take the sum of fx divided by the sum of f. This is going to be an estimate for the mean. 251.9 divided by 64 equals to 3.9. So an estimate height for the mean is 3.9 meters. Question number 8. A biologist is going to estimate the number of woodlice on a small patch of waste ground. She uses the capture-recapture method. She catches 200 woodlice and marks them with a small spot of paint. These woodlice are then set free on the patch of waste ground. A few weeks later, she catches 200 woodlice. 8 of them are marked with paint. So we need to find an estimate for the number of woodlice on the patch of waste ground. To be able to find an estimate, we must take the number originally caught, 200 divided by the proportion, m is equal to the proportion of the second sample that are tagged. So here we can find m by taking 8 divided by 200, which is 0.004. So here our estimate is going to be equal to 5,000. You're then asked to write down 2 assumptions that the biologist made when working out this estimate. Now, the 3 things we listed earlier in this session were that the number in the population is unchanged between the samples. So during these few weeks, the number of woodlice stays the same. Second, that the spot of paint, the marking, does not come off. So when she captures them and then recaptures them, the spot of paint is still there. Also, a further assumption is that the woodlice that have a mark on them spread evenly throughout the population. So when they are captured and then released and go back into the population, they spread evenly. So they are 3 assumptions. You need to list 2 of the assumptions here. So we've now come to the end of session 3. Please revise the list of topics shown here on the screen and replay the video for any sections that you would like to study again.